It turns out that complex numbers can be represented on a plane as well. The plane at which complex numbers are represented is called Argand diagram. In an Argand diagram, its y-axis is now the imaginary axis, and its x-axis is now the real axis. Well, the purpose of this video is to show you how to represent complex number on an Argand diagram. All you need to do is to pay attention to the component of this complex number in each axis. Since you know that complex numbers that are expressed in the rectangular form will have two components: its value along the real part or for the real part, and its value for the imaginary part. So pay attention to its value for the real part. Then you are going to move in that unit along the real axis. Then you repeat the same thing for the imaginary axis. You move along that same unit. Then you find the point of connection. If this is along the real axis and this is along the imaginary axis, so drawing a line to join these two distance, then we have the complex number itself. So that's how to easily represent complex number on an Argand diagram. So let's consider some examples. Considering the Argand diagram on the board, let's say we have a complex number z that is equal to 2 plus 5i, for instance, and we are required to represent this complex number on this Argand diagram. How do we do that? Well, the first thing is to pay attention to the component of the complex number along the real axis, and its value turns out to be 2. Then we locate 2 along the real axis. So the highlighted spot is for 2. So this is 2. Then we can just draw a dotted line until we reach 5 along the imaginary axis. So let's assume the 5 is in between, somewhere around here, between 4 and 6. So drawing a line, to make it a dashed line, to join these 2 points, and I can have the complex number. So the complex number will be this straight line from the origin then to the point of contact. So this is z. So that's how to easily represent a complex number. Very straightforward. So let's consider another example. So what if we have a complex number z that is equal to 10 plus 8i. So how can we represent this? So first thing first, you locate 10 along the real axis, which is here. Then secondly, you locate 8 along the imaginary axis, which is here. Then we join them together with a dashed line. And after that, we draw a straight line from the origin to show the vector form of the complex number. So this is z. So if this one is z2 and this one is z1, we have z2 right here. So that's it. And if it's negative, then it means you'll be having the negative part. There's no anything difference. Now that you know how to represent complex number on an Argand diagram, what if you are given the represented complex number already and you are required to express it in rectangular form? How do you do that? Let's look into that as well. Express the following complex number in a rectangular form. So we have the one in white color, the one in green color, and the one in red color. So we'll be using their color to solve them. Let's start with the one with white color. Well, since you know that any complex number in rectangular form will be of the form z equals x plus yi. It means your goal is to pay attention to the component of that complex number along the real axis. Then you take that value as your value of x. You do the same thing for the imaginary axis and you take it as your value of y. And then you substitute respectively and have your complex number. So z in this case will be equal to, let's find its magnitude along the real axis. Can we say it's 10? Does that make sense? That does make sense. So we can say 10. So the value of x is 10, as that corresponds to the unit of the complex number along the real axis. Plus, now what about along the imaginary axis? If we draw a dashed line, can we also say 10 or 9? Let's work with 10. You know, if it's going to be tested like that, it's going to be on a graph, and it will be easy for you to identify the exact value. You understand? So generally speaking, the complex number is 10 plus 10i for the white color. So onto the one in red color. So what will be its magnitude along the real axis? Well, this should be negative 10 to see. Bye-bye. Because this along the negative real axis, so that should be minus 10. While this is positive, that's okay. Now the units moved by the red color z complex number along the real axis, we can set negative 8. We can clearly set that. So we can set minus 8. I'm using white. Let me use red. Minus 8. Then along the imaginary axis, we can set minus 6. Minus 6i. Perfect. And for the other one in green color, its units move along the real axis. I just said positive 2. I think that makes sense. Or we should say 1.8. But let's work with positive 2. So that will be equals to 2. Then along the imaginary axis, that's just negative 10. Then minus 10i. So it's kind of straightforward. The goal is just to be tracing that complex number. You trace it along each of the axes in order to know the magnitude which it moves along each of those axes. So that's how to easily do it. So I hope you find this helpful and understandable, and I want to believe in one way or the other you now know how to represent complex number on Argand diagram and how to express a represented complex number from Argand diagram into the rectangular form. Thanks for watching. See you in the next video. Bye for now.